Have you ever just wished you could hand an AI a bunch of your own documents, like your company's internal reports, a textbook, whatever, and have it instantly become an expert on it? Well, today, we're going to break down exactly how you can build a custom AI brain that knows your data inside and out.
And that's really the big question, isn't it? You don't want generic answers scraped from the whole internet. You want specific, smart responses that come directly from a knowledge source that you provide. So how do we do that? The answer is this really powerful technique called Retrieval Augmented Generation, or as everyone calls it, RAG.
So let's just dive right in. And look, forget about picturing complicated lines of code. The absolute best way to get your head around RAG is to think of it like a big set of Legos. Seriously, each piece has a very specific job, and you can just snap them together, swap them out, and build the exact AI you need. It's all about being modular.
Okay, so to really understand how these blocks fit together, let's start with a basic blueprint. We're going to walk through a pretty standard setup just to see how all the core pieces connect before we start getting creative with our customizing.
At its heart, pretty much every RAG system follows these 5 steps. First, you load your document. Easy enough. Then you split it into smaller, more manageable chunks. Next, and this is the magic part, the system embeds those chunks. That's a fancy way of saying it converts them into numbers called vectors. Think of it like turning words into coordinates on this giant map of meaning. After that, you store those vectors in a special database. And finally, when you ask a question, the system retrieves the most relevant vectors and uses them to generate an answer. It's a simple but incredibly powerful pipeline.
So to make this a little more real, let's imagine we're feeding the system that massive 144-page annual report from Berkshire Hathaway. We could use a tool like Pinecone as our vector store, that's the AI's long-term memory, and then use OpenAI's models for both creating the embeddings and generating the final answers. This is a classic, super powerful setup.
Now, pay attention to this slide, because this one number is so important. When you're using OpenAI's embedding models, this is a non-negotiable rule. Your vector database, whether it's Pinecone or something else, has to be configured to use exactly 1536 dimensions. It's one of those tiny little details that can make the difference between your system working perfectly or just not working at all.
And this is where the real fun begins, because it shows you the true power of RAG. You are not locked into that first build we talked about, not at all. Every single piece of that pipeline is a swappable block. So let's look at how you can mix and match to create the perfect system for whatever you're working on.
Let's start with the input block. You are not just limited to PDFs, not even close. Thanks to frameworks like LangChain, you have this huge library of document loaders ready to go. You can feed your AI text files, you can have it scrape live web pages, connect to entire GitHub repositories, you can even pull data directly from your Notion pages or Figma designs. Basically, if you have data somewhere, there's a pretty good chance you can connect it. Okay, next up is the memory block, your vector store. And this choice really matters. A fully managed cloud solution like Pinecone, super fast to get started, but it does mean your data's living on their servers. An option like Qdrant is really flexible because it lets you choose between their cloud or hosting it yourself, which gives you total control over your data and your costs. That's huge for sensitive company docs. And the in-memory store? That's your quick and dirty sandbox for when you're just testing things out locally. Now, the translator block, your embedding model, is another huge choice. This directly impacts how well your AI actually understands the subtleties of your text. OpenAI is kind of the industry standard, it's really powerful. But what if your documents are in a bunch of different languages? Well, that's where a model from Cohere would be perfect, since it supports over 100 languages. Or if you just want to play around and experiment, you can tap into the whole world of open source models over on HuggingFace. And the most important point here is that you can combine blocks from totally different companies. For example, you could totally use Cohere's multilingual model to create the embeddings from a document, but then turn around and use OpenAI's GPT 3.5 Turbo to generate the final, polished answer. You really do get the best of both worlds.
All right, you've got the basic blocks down. Now let's get into some pro builder tips, straight from the field. These are going to dramatically improve the quality and reliability of your custom AI brain.
First one up. Temperature. This setting basically controls the AI's creativity. Now, when you're building a RAG system to answer questions based only on a document, you don't want creativity, you want facts. So the pro tip here is to set the temperature to 0 or something super low like 0.1. That forces the model to stick to the script, literally.
Okay,
This piece of advice right here is absolutely critical for building a system you can rely on. You need to separate your workflows. Have one process that is only for adding data to your vector store. That's called an upsert flow. Then, create a completely separate flow for asking questions. Why? Because this stops you from accidentally re-uploading your documents every single time you ask a question, which just creates a mess of duplicate data and leads to really unreliable answers.
You also have a bunch of other levers you can pull to control your AI's output. A system prompt lets you give the AI a personality or specific rules, like, you are a helpful assistant who only responds in English. You can also change the chain option. For instance, a method called MapReduce is awesome for huge documents because it processes all the chunks at the same time. And you can adjust top K, which tells the system exactly how many of the most relevant text chunks it should look at before it forms an answer.
All right, now for the ultimate expression of this whole building block idea. What if one toolkit, say Flowise, has a document loader you really need, but another one, like LangFlow, has some other feature you love? Can you actually get them to work together? The answer is yes, absolutely.
That's right. You can actually build a system where part of your pipeline is in one platform and the other part is in a completely different one. I know, it sounds like it should be complicated, but it works perfectly as long as you follow two simple golden rules.
And here they are. It's this simple. First, both systems have to be connected to the exact same vector database. That's their shared memory. Second, they have to use the exact same embedding model. This makes sure they're speaking the same numerical language. As long as you do those two things, the vector store acts like a bridge, and the platforms can work together like one big cohesive brain.
So there you have it. We've seen that retrieval augmented generation isn't just one thing, but this powerful modular toolkit. You've got your input blocks, your memory blocks, your translator blocks, and your brain blocks. You can mix them, match them, and connect them in pretty much endless ways. So the only question left is, you've got the blocks. What are you going to build?